SPIRAL2 to create man-made stars that could help fight cancer. A particle accelerator will create nuclei that are not found on Earth by shooting dense beams of ions over a 40-meter tunnel. A new particle accelerator dubbed SPIRAL2 that could boost cancer treatment and provide safer nuclear energy is to be unveiled. Scientists will study where nuclei, which are 10,000 times smaller than the atoms they sit in, come from, how they are forged and which forces govern their behavior by creating the extreme conditions present inside stars. Although the atom nucleus was discovered in 1911 and its constituent parts about 2 decades later, scientists know little about nuclei. The Euro 138 meters project, based in Caen, northwest France, will synthesize and examine so-called exotic nuclei which are usually forged in the cores of stars and not found on Earth. Hervé Savigils, the project's scientific coordinator, said they hope to produce radioactive nuclei which will give off a very strong localized radiation that could be used for treating tumors. The super tiny particles could be injected into cancer patients to produce radiation only when they reach the targeted tumors without damaging any non-cancerous tissue, unlike current treatments. It is also hoped the research will help design a safer and more environmentally friendly method of generating energy for nuclear fission which involves splitting atoms with neutron beams. Jean-Charles Thomas, a researcher at France's CNRS Science Institute, said, "We want to understand how these matter-building elements are produced under the extreme heat conditions found in stars. Scientists will shoot dense beams of ions, atoms stripped of some of their electrons, over a 40-meter tunnel about 10 meters underground." Mr. Thomas said, "We will create what happens inside stars in the laboratory. The beams will explode against a target surface and disintegrate into subatomic particles, including nuclei. Many of them would never have been seen on Earth. It is hoped the experiment will help explain why different nuclei have different proton-to-neutron ratios, which is what determines the charge of an atom and the chemical element it belongs to." A statement on the project said, "SPIRAL2 will give access to a whole range of experiments on exotic nuclei which have been impossible up to now. In particular, it will provide intense beams of neutron-rich exotic nuclei whose properties are little explored at present. SPIRAL2 will form part of the GNUL Heavy Ion Accelerator and Caen project of France's Atomic Energy Commission, CEA.